Today we'll begin with the topic structure of an atom. Let us first begin by defining what an atom is. An atom is the smallest particle of an element which can take part in a chemical reaction. So now let's define what an element is. An element is a pure substance made up of only one kind of atoms which cannot be broken down into simpler substances by physical or chemical means. Protons. Now we'll define particles that are present inside an atom. Those are called subatomic particles, of which first is proton. So a proton is a positively charged particle present in the nucleus of an atom. Next up, we have neutron. A neutron is a neutral particle present in the nucleus of an atom. Then we have electrons. An electron is a negatively charged particle that revolves around the nucleus along imaginary paths known as shells or orbits. Okay, now let us see what an atom looks like. At the center we have a nucleus which has protons and neutrons. Around the nucleus are shells, first shell, second shell and third shell. First shell contains 2 electrons, second shell 8 electrons and the third shell over here has 1 electron. We are taking an example of sodium over here, we'll discuss about the electronic configuration in the second lecture of this chapter. So let us see what these atoms look like, these particles, subatomic particles look like. First up, let's see for protons. We represent protons by writing P. Its mass is 1 and its charge is +1. So charge being +1, mass 1. Neutrons. A neutron have mass of 1. It has no charge. Here 1 means 1 atomic mass units, AMU. And electrons. Electrons are represented in this manner. It has negligible mass and its charge is -1. We take it as 0, but its mass is negligible. It's actually not 0. Now let's see what an atomic number is. The number of protons in the atom of an element, or we also define atomic number as the number of electrons in the neutral atom of an element. Some important notes. First up, an atom does not gain or lose protons, but may gain or lose electrons. So electrons may be lost or they may gain electron, but losing a proton or gaining a proton is not possible for an atom. Second, neutral atoms have same number of protons and electrons. So electrons are lost or gained, but protons are neither lost nor gained. That is why atomic number, when we define, we can say the number of protons in the atom of an element. So it need not be neutral. It may have lost or gained an electron, but its atomic number will remain same if we consider protons. But if we define it according to the number of electrons, we need to mention neutral atom is because an atom may gain or lose electrons. That is why this neutral over here is important. Third point. The number of protons determines the charge positive of the nucleus in an atom. Why are we saying positive? Is because the nucleus contains protons and neutrons. Neutrons are neutral, they do not contain any charge, whereas protons are positively charged. Hence, the nucleus overall is positively charged, and the protons determine the charge present in the nucleus, or we call it as the nuclear charge. The value of nuclear charge is equal to the atomic number of the element. Mass number. So what contains the mass? What makes the mass of an atom? See, electron is negligible. So protons and neutrons together make up the mass of the atom. That is why when we calculate mass number, we calculate the total number of protons and neutrons. These are collectively called nucleons in the nucleus of an atom. An important note: mass number is slightly less than the actual atomic mass, because mass number is the whole number approximation of the atomic mass in atomic mass unit. See, why is this slightly less is because the mass of electrons is negligible. It is not zero. That is why when we consider mass number, since we are calculating the number of protons and neutrons, electrons is getting neglected. That is why mass number is slightly less than the actual atomic mass. Next up, we have shells. So, electrons revolve around the nucleus in definite orbits called shells. Some important notes about shells. First up, the shells are also called energy labels because while revolving in a shell, an electron possesses a certain amount of energy. Number 2, an electron has minimum energy in the K shell for shell and the energy increases in the order K, L, M, N. K is the first shell, L the second shell, M third shell, and N is the fourth shell. We will only be dealing with 4 shells in our syllabus. That is why we are not proceeding any further. But it goes on in this manner: K, L, M, N, O, P, and so on. Also, suppose there are 2 electrons in the K shell. So, this certain amount of energy possessed in both the electrons in the K shell is fixed. That is, if suppose one electron has a certain amount of energy, the other electron will also have the same amount of energy in the K shell. Okay, please leave certain space and start on the left hand side of the page with this chart. First, write the atomic number, then the element, symbol, number of protons, number of neutrons, mass number, number of electrons, electronic configuration, valency, and finally nature. Electronic configuration, valency, nature we will be discussing in the next class. Today we will complete till the number of electrons. So atomic number, first up we will write till 20. Begins with hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. The symbols are number of protons will remain same as the atomic number. For number of neutrons, there is a simple technique For all the even numbers, it remains even itself, the same. There are two exceptions. One is the second even number from the beginning and the second even number from the end. Remember that this is just an observation. You can use this technique or you can learn it directly. And for odd numbers, again there are two exceptions. One is for hydrogen, which has zero number of neutrons, and nitrogen has the same number of neutrons. The rest, all the odd numbers, will add 1 to them. So 3 becomes 4, 5 becomes 6, 9 becomes 10, 11 becomes 12, 14, 16, 18, 20. And for beryllium, it increases by 1, becomes 5, and argon is 22. Calculating mass number is very simple. You just need to add the number of protons and the number of neutrons. You can easily calculate the mass number, and the number of electrons will remain same as the atomic number. So we have this much for today. Make sure you complete mass number and you learn all this for today's class. In the next lecture, we'll proceed forward with electronic configuration, valency, nature, and some more detail about the chapter.